Okay, so this is a short description on how to answer a past paper question on the little man machine, little man computer, or a machine code. So you should have watched the other tutorials on machine code and what the different uh, operators mean, like IMP, STA, STA load, but it still doesn't necessarily mean that you're able to answer. Just turn the screen off. Answer the questions that are in the past papers, because sometimes they give you quite complicated machine code. So how can you work out how any piece of machine code works? So what you need to do is you need to create a trace table like this. And you just write out down a trace table, and it will help you think through this quite complicated code. And we'll go through one example, because what they do is they give you this piece of code, and then they give you which I've also got here, and then they give you some inputs. So you input 12 and 5 into this computer program. What are you going to output? Well, what we need to do is we need to write down the different variables we got. So we've got in each column, we've got number 1, number 2, 1, count, and then there's some key operations in here, for example, like subtract here. You're subtracting whatever is in the accumulator, num2 from whatever is in the accumulator on that line there. And then BRP positive. So this is a loop. This piece of code is basically a loop, and it keeps looping while what is in the accumulator is positive. And on every loop, it takes away the previously calculated number, and once it becomes -0 or negative, it ends. Right. So, for example, inputs are 12 and 5, right? And this is going to output 2 and 2, as I'll show you in a minute. So we're going to input. So read the code. Input, store that input in number 1. So we're going to store 12 in there. And then input, store that in number 2. So we're going to put 5 in there. 1 is just 1. Count is 0. And then we get down to these other lines. We load number 1 into the accumulator. And then we subtract whatever value we stored in number 2 from number 1. So whatever is in the accumulator, we're going to subtract number 2 from it. Basically, we're going to subtract 5 from 12. So what is the sum of that? That is 7, right? Now, next test is what is the result of that calculation positive? Yes, it is. So true. So if it's true, then we just jump to pos. So then we jump to pos. We store number 1. So this gets stored in number 1. Then we're going to load the counter. So we're going to load the counter, which is 0. We're going to add 1 onto it. Basically, add 1 onto the counter. 1 is always going to stay as 1. And then we're going to store the count back in there. So you're increasing the count. And then we're going to branch to main. So we jump back up to here. Then we're going to load number 2 stays the same. We're going to load number 1 back into the accumulator, 7. And then we're going to subtract number 2 from number 1, which is in the accumulator. That should give us 2. Is that positive? Yes, it is. True. Then we go on. Then we're going to store that result into number 1, as I said before. Number 2 stays the same. 1 stays the same. We're going to increase the count to 2. And then we're going to branch back up to here. Then we're going to load number 1 into the load number 1 and subtract number 2 from it. So that's 2 minus 5, which is -3. So this is no longer positive. False. So this is not true anymore. So then we get into this bit of the program here where we load the counter, which is 2, output it 2. So that's our first output, you see. So we're going to output. Hopefully you can see this. It's not too small. We're going to increase the size of that a little bit just because it's on the video. Probably should have done that before. So we're going to output 2. And then we're going to load number 1, which is at 2. And we're going to output that as well. So you can see what have we got here? Well, you input 12 and 5, you get 2 and 2. Or what you've got is the number of times it's gone into it, twice, remainder 2. So count is counting up the number of times 5 goes into 12. And then number 1 is the remainder. So you just output 2 and 2. And then you see, we've already worked that out. We know what's going on now. So what we can do is we don't have to run through that program in our head with the trace table, but we know that we're just dividing number 1, which is the next example, is 18. So if we input 18 and we divided that by 2, we know that our output is going to be 2 into 18, which is 9. And it goes exactly, so it's remainder 0. So we don't need to do the calculation. We've understood what the code is doing. It's finding the quotient, the number of times the thing goes into it, and it's finding out what the remainder is. So yeah, that is how you can work out any computer program in machine code. Write out a trace table, write out the key variables, write out the key decisions that maybe mean you branch another bit of the code, and then you'll be able to see it a little more clearly. Once you've understood what the program's doing, you'll understand what the code is doing, and you can answer the other questions like this. And then, for example, in the last one, it says write the algorithm using pseudocode that has the same functionality. Well, now we know we're going to have to write an algorithm where you're going to input 2 numbers, you're going to divide 1 to get the quotient, the number of times it goes into it, and then you're going to have to do a mod, which is the percent on that as well, to find out what the remainder is, and then output those 2. So that would give you those 4 marks and those 4 marks as well, just by doing a simple trace table like this. And if there are any program questions in an exam where you don't understand the code, write it out like that and loop through it and see what goes on. So you could do the same for binary search or any of the other sort algorithms if you're not sure.